Hi everyone, this is Mrs. GA, and today we are going to be finding equations of parallel and perpendicular lines. So in this first example, we're asked to find the slope of the two lines to the right. So remember, we can either find 2 points and then use our slope formula, which is right here, or we can interpret the rise over run just by looking at it. So for line A, I'm going to start by finding 2 coordinates that I know. So again, I'm not going to pick a coordinate that's somewhere in between. So I'll pick these 2, and then I'll just do the rise over the run. So to go from my left point to my right point, I have to go up 2, right 3. So that means that my slope is 2 over 3, rise over run. Let's see if we can find the slope of line C. So again, pick 2 nice points. They could be anywhere on your line. So I'm going to use these 2. And let's do rise over run again. So I have to go up 2, right 3. So I see that I have the same slope of 2 over 3. So we can tell that these lines are parallel. Yes, they are parallel because they have the same slope. And remember, if 2 lines are parallel, that means they will never cross. So imagine if you are going up and over at the same rate for both, they will never cross. Now let's look at this next example. So this says, on the figure to the right, draw a line that is parallel to the line in the figure. So to draw a line that's parallel, we find the slope of the first line. So again, let's find 2 nice points. I'm going to use this one that was given to us here, and maybe I'll use this point right here. So remember, we always go left to right. So for this one, I have to go down 1, right 2. So I'm going to use a slope of -1 over 2. So I'm going to make a note of that over here. My slope should be -1 over 2. So I can start anywhere I want on my graph because I am making a line that is parallel to this one. So pick a point anywhere. So I'm going to say, how about right here? And then I'm just going to follow my slope of -1 over 2. So I keep going down 1 over 2, down 1 over 2. And then if I connect my points, I see that this line is parallel to my original line. In number 3, they ask us to be a little more specific. So they say, draw a line that is parallel to this line, but also passes through the point 3, 1. So I need to start at the point 3, 1, which is right here, but then I am going to follow this same rise over run. So I'm going to go down 1, right 2, or I can go backwards, up 1, left 2, up 1, left 2, and then I'm going to draw my line. So there you have it. So in this next example, first thing we're asked is to use your protractor to determine if the 2 lines are perpendicular. So if you measure these 2 lines with your protractor, you will find that the angle between J and K is exactly 90 degrees, which means that they are perpendicular. So let's see if we can find the slopes and look for some sort of pattern between perpendicular lines. So let's start with the slope of line J. Again, let's find some points that we know. So I'm going to use, let's say, how about this point and this point? So moving left to right, I see that I have to go down 2, right 1. So my slope is -2 over 1. Let me record that to the left. So -2 over 1, which of course is just -2. And now let's find the slope of line K. So again, find 2 points that you know. So I'll go from here to here. So I have to go up 1, right 2. So my slope is 1 over 2. So if you compare these 2 slopes, what you might notice is that the slopes of perpendicular lines are reciprocals. So see that 2 over 1 becomes 1 over 2 that are also opposite. So notice that 1 is negative and 1 is positive. So that brings us to recalling some rules from Algebra 1. Parallel lines always have the same slope, which we determined in that first example. And perpendicular lines have what we call opposite reciprocal slopes. So we're going to be using both of these facts today. And we are going to be writing equations of lines. So here's a little more Algebra 1 review. It's a review of two different ways that you can make the equation of the line. So the first one is a point slope formula review. So the point slope formula is right here. Y minus y1 equals m times x minus x1. So you only need two things to find to make your equation. You need a point, any point, so that will be x1, y1, and then your slope. So if you're given the slope and a single point, you just substitute your values and then you distribute and solve for y. So it's pretty easy to use. If you choose to use y equals mx plus b to make your equation, that's fine as well. But we do need to know the slope and the y-intercept. So if you're not given the y-intercept, you can still use the slope and then a point, maybe an xy point that you may be given, like you see here. And then you have to solve for b, which you then plug back into your equation. So remember, for slope-intercept, you need the slope and a specific point, the y-intercept, which you can find. It just takes a little bit more work. So when you're writing an equation, you can decide which method you would like to use. It's more of a preference thing. So for this first one, I'll show you how to do it with both methods. So here they ask us to find an equation of the line that passes through the point 6, -1 and is parallel to this line. So the first thing that I like to do whenever I see the word parallel, I like to say same slope to remind me. So I can look at this equation. I see that my slope is 8. So that means the slope of my new equation will also be 8. So see, here we have the slope and a point. So let's start by using point slope, which this is my point slope formula again. So I'm just going to substitute. So I do y minus y1, which is -1, equals m, which is 8, times x minus x1, which is 6. So here I can do y plus 1 equals, and then I'm going to distribute 8. So 8 times x is 8x. And then 8 times -6, and then I'm just going to solve for y. So all I have to do is subtract 1 from each side, and I have y equals 8x minus 49. Now we can do the same thing again using slope-intercept form, y equals mx plus b. So I'm going to substitute m, x, and y so we can find b. So we have -1 equals 8 times 6 plus b. So if I subtract 48 from both sides, we get -49 equals b. And then I need to go back and substitute m and b into my equation to get my final answer. So we get y equals 8x minus 49. So you can see that I get the same exact equation. So again, this is going to be a personal preference thing. Pick whichever method seems easier to you. So at this point, please pause the video and see if you can give this example a try. We'll check our answer in just a few seconds. Okay, go ahead and check your work. So I use point slope formula, so y minus y1 equals m, so it should have the same slope as this line, times x minus x1. And then I got y equals -2x minus 14. If you use the slope-intercept form to find this equation, you should get the same answer. All right, for number 3, let's try this one together. Find the equation of the line that passes through -4, 3, and is parallel to the x-axis. So remember, parallel means same slope. Let's think about what the x-axis looks like. This is our x-axis. It's a horizontal line. So I know that the slope of a horizontal line is always just 0. So it's asking us to find the equation of a line that goes through this point with a slope of 0. So again, let's use point slope formula. So y minus y1 equals m, which is 0, times x minus x1. So I have y minus 3 equals, well, this 0 is going to turn this entire side to 0, and then I just add 3, and I have y equals 3. So remember, this is what the equation of a horizontal line looks like. You will only see y, you won't see x in your equation. All right, so now let's try some with perpendicular. So this first one says, find the equation of the line that passes through -4, 5 and is perpendicular to y equals 2x plus 1. So remember, perpendicular lines have opposite reciprocal slope. I'll do m for slope. So I see that this line has a slope of 2, and it might be helpful to write it as 2/1. So I know that the slope of my perpendicular line will be the opposite reciprocal. So again, this is positive, so this becomes negative, and then 2/1 becomes 1/2. So now I have everything I need. Let's use point slope again. So y minus y1 equals m (-1/2) times x minus x1. So I have y minus 5 equals (-1/2) times x plus 4. Now I need to distribute (-1/2), so y minus 5 equals (-1/2) x. So remember, this just means (-1 times 4 divided by 2. So again, we have (-4 divided by 2, which is (-2). And then add 5 to both sides, and we get our equation. Okay, why don't you pause the video and see if you can give this problem a try. All right, let's check our work here. So this line has a slope of -4, so our perpendicular line will have a slope of positive 1/4. And then I use point slope formula here, and I got y equals 1/4 x plus 2. All right, let's try this one together because it's a little bit more conceptual. So this one, they would like us to find the equation that goes through this point and is perpendicular to the x-axis. So our x-axis looks like this. It's perfectly horizontal. So we know that a perpendicular line will be perfectly vertical. So we're looking for a vertical line that goes through this point. So remember, vertical lines always have the form of x equals some number. So if you want to know which number, look at the point and take the x value. So it's simply x equals 7. All right, this last one is a little bit tricky. So here they say find the equation of the perpendicular bisector, so perpendicular bisector, of the segment in the figure below. So let's recall a perpendicular bisector is perpendicular to your line, but also goes through the midpoint because it cuts your point in half. So since we want to find the bisector, we need to figure out where the exact middle of line AB is. So first we need to find the midpoint of AB. So that is going to require that we use the midpoint formula. So remember, you add up your x values and cut it in half, add up your y values and cut it in half. So it's a pretty simple formula to use. So if I add up the x values of a and b, I get -2 plus 4 over 2. Add up the y values. Here I get 2 over 2, which is 1. And here I get 6 over 2, which is 3. So they want the equation of the line that goes through the point 1, 3 and is perpendicular to this line. So I know that I'm going to need to find the slope of this line so I can figure out what the slope of my perpendicular line is. So let's go from here to here to find the slope. So I have to do rise over run. So you can see that I rise 4 and I run 3. So the slope of this line is positive 4 over 3, which means the slope of my new line will be negative 3 over 4. So now I just need to find the equation of the line that meets these two requirements. So I'm going to do point slope formula. So I do y minus y1 equals m times x minus x1. So y minus 3 equals -3/4 x. Remember, a negative times a negative will give us a positive. So we have positive 3/4. From here, I see that we need to add 3 to both sides to solve for y, and I'm going to do that on the side. Yes, we are adding fractions, but I think if you show your work on the side, it becomes much easier. So I'm doing 3/4 plus 3/1. So I know that I need to change my denominator by multiplying by 4/4. So I have 3/4 plus 12/4 equals 15/4. So I get y equals negative 3/4x plus 15/4. And there you have it. So again, this one is a little bit trickier because you have to figure out the midpoint so you know which point it goes through, and we have an equation with some fractions. But I think if you show out all your steps, you should be fine. All right, that is all for today's lesson. Thank you so much for watching.